Welcome to the Spring Boot Crash Course. This video's mission is to teach you enough Spring Boot that you can get up and running and experimenting with the framework. To this end, I'm not going to be teaching you every single little Spring Boot feature, just the ones I consider most important for you to get up and running, the ones that I would have really wanted to know when I started using Spring Boot all that time ago. For those that don't know me, my name is Aaron Bourne, I'm a software developer and I'm the lead trainer at DevTiro. But that's enough of that, let's get right into it. So Spring Boot is a framework, and I think we should discuss what a framework is. So I went on the web and I grabbed this definition here. Framework, abstraction, generic functionality, it's pretty complicated, right? So I'm going to take some liberties and we're going to use this definition today, which is one of mine. A framework is a chunk of code written on top of a language's core library to solve common problems so you don't have to. So like the world's flakiest pastry, software is all about layers. So that framework layer sits above the language's core library and just below the app that you're building. This is vastly simplified, but this is the gist of it, right? So a framework, it's there to solve problems like connecting to a database or exposing something like a REST API. And one such framework is the Spring framework. Notice I said Spring framework and not Spring Boot because they're actually different things. So Spring Boot is actually another layer, it's something different that sits on top of Spring Framework, and its purpose is to make Spring Framework easier and simpler to use. So Spring Framework is where all that functionality is, connecting to databases or exposing REST APIs, and Spring Boot just makes all of that easier. And that's because of Spring Framework's biggest benefit, but equally its biggest drawback, and that's that it is highly configurable. And guess who's configuring it? Well, you are. That is unless you're using Spring Boot, which does a whole lot of the configuration for you and makes things a lot easier. But that's really only part of the story, because we haven't touched on how Spring Framework makes all of this functionality available to you, and that's through Dependency Injection. So there's this thing called the inversion of control principle, and it's a pretty broad concept, but the version that we care about is this. Let's take a class, and that class is completely capable of creating its own dependencies, so creating concrete classes that it relies on. And that's one way of doing things, but it's not that flexible. We can invert the control so it becomes more flexible, and this is how we can do it. So rather than relying on concrete classes, we can follow best practices, and that class can rely instead on interfaces which define behavior. And then something around the outside, a framework for example, can then create the concrete classes that implement those interfaces and make them available when they're needed. In this way, you can see that the control is inverted, so it goes from belonging to that individual class, relying on the concrete dependencies, to something operating at a much higher level, in this case, the framework. So this approach has all sorts of benefits, but perhaps the biggest one is flexibility. So when you want to change the behavior of something, this is how you do it. You just define a new implementation for that interface and then configure the framework to make that new implementation available. Easy as that. This particular pattern of inversion control was labeled the Dependency Injection pattern by the Software Hall of Famer Martin Fowler. Spring Framework is many things, but at its core, it's a dependency injection framework. So it solves the problem on how to wire together different software components in a way that's flexible. And we've discussed a lot of the theory behind that, but haven't actually discussed how it does it. We've touched on the first thing though, which as developers, we need to follow best practices and code to interfaces and not concrete classes. And this is said to decouple our classes from their dependencies. Now, how do we actually declare the dependencies for our class? Well, here's the first way. So here we have a code snippet, and this is the book controller. So it's part of a REST API implementation. And the book controller has a dependency, and that dependency is the book service. Okay, so how do we get that book service into the book controller? How do we rely on that dependency? How do we use it? Well, we can see the constructor here. So the constructor has an argument of the book service that is simply just assigning to a local instance variable book service, and you can see that used throughout the class, and that's the orange arrows there. So one of the benefits of this approach is that the private instance variable book service is made final. So once it's assigned in the construction, it cannot be reassigned, which is great. It makes things a lot simpler and less confusing. So this is the recommended way of getting those dependencies into your class. We've been using the term injection so far, and it's correct, but there is also a Spring specific term that you should be aware of. It means exactly the same thing, and that term is auto wiring. And we're going to be using these synonymously from now on. So this is another way of getting your dependencies into your class. We can see here we still have the book controller and it still relies on the book service, but there's no constructor. Instead, the book service instance variable has the auto-wired annotation above it. So it amounts to the same thing really. The book service is still injected into the books controller, but you can see that this instance variable can no longer be final, which means it can be reassigned after it's initially assigned, which can be a bit confusing. So while we're starting to use the Spring lingo, we should probably replace the term implementing classes. It's far too many syllables anyway. Let's call them what Spring calls them, which is beans. Yeah, really. So where does Spring get its beans from? Let me tell you. In days gone by, it used to be done via XML config files. So you used to put all your beans and their dependencies into that XML config, and when your app started up, it would read it, and it would either start up fine, or if there's some sort of problem, it wouldn't. Now, I for one am pretty glad we no longer do that, and we use Java config instead. Let me show you what that looks like. So we're going to create some bean declarations using Java config. So what we have here is the main class. And we can tell it's the main class because slap bang in the middle, there is a main method, and it's also annotated with the SpringBootApplication annotation, but we're going to talk about that in a little bit. The bit we should talk about now is this method book service. This is a bean declaration, and we can tell this because it has the bean annotation on top. So this particular method returns the type of book service. So it's a bean of book service. And we can see here that the concrete implementation of book service is the book service import. We can also see that there is a dependency involved, the book repository. So the book repository dependency is declared as an argument to the method book service. So when Spring starts up, it's going to look for the book repository, make it available to this method. This method is going to create the book service import, and then there's going to be a bean of book service available to the rest of the application. So once you've defined a bean, it gets put into the inversion of control container, and it gets to hang out with all the other beans. Now when your app starts up, yeah, Spring is going to go looking for beans, but it's also going to go looking for everywhere a bean is needed. Now if Spring can find a bean for everywhere that a bean is needed, then your app starts up absolutely fine. But if not, your app won't start and you'll get told which beans are missing, at least with the default configuration anyway. Now there are some other ways of defining beans, but to understand them really, we're going to have to explore some other Spring concepts first. Let me drop some facts on you. So Spring supports 3 different languages. You've got Java, obviously, and then you've got Groovy and you've got Kotlin as well. Fun, right? So we're going to give all of our examples in Java, but if you want to use any of the others, go for it. Choice is yours. So that's decision number 1 when you start a Spring project. So decision number 2 is which build tool you're going to use. At the very basics, this is the thing that you give your code to and it gives you an app you can run. Well, we're taking some liberties, but yeah. So the 2 that you can choose from are either Apache Maven or Gradle. You can hook up some others, but nobody's got that time. So Apache Maven is kind of the old school version, which is driven by XML configuration. It might be old, but it is bulletproof, and we're going to give all of our examples in Apache Maven. You can use Gradle, and that's kind of the newer school way of doing things, and if that's more your style, go for it. So these tools do a few different things. They build your code, they manage your dependencies, they package your code, and they do some other stuff as well. But we're going to focus on the dependencies right now. Because Spring is built around this inversion of control dependency injection pattern, it can really embrace modularity. So if you want to connect to a database, you just grab the dependency for that. If you want to expose a REST API, you just grab the dependency for that. It's really easy. But this really goes back to the Spring Boot versus Spring Framework thing. So if you were using just Spring Framework, yes, you'd have access to these beans, but you'd have to configure them all yourself. Whereas if you're using Spring Boot, it will configure them for you by using those well-known conventions. It will default the configuration, if you will. So let's take this one step further. Let me tell you about the Spring Boot starters. As devs, we typically want to solve the same problems over and over again. So for example, this app is a command line app, or this app is a REST API that connects to a database, or this app is an event-driven microservice. The Spring Boot starters are dependencies which you can import, and it solves these problems for you pretty much out of the gate. For example, if I wanted to build a web app or a REST API, I might import the Spring Boot starter web dependency. If I wanted to connect to a database, I might import the Spring Boot starter data JPA dependency, which not only allows me to connect to a database, but also interact with it using Java objects. And you can import more than one starter. But that might seem pretty complicated, but Spring has given us a tool to make it a lot easier. Let me show you the Spring Boot Initializr. So here's the Spring Boot Initializr, and you can find this at start.spring.io, and this is going to allow you to create a skeleton project of a Spring Boot application, but with all the dependencies that you need and the configuration that you need. So let's just take a quick look through it now. So we've just hit the website, and we can see here we select our project. Now we're going to be using Maven, but if you wanted to use Gradle with Kotlin or Gradle with Groovy, that's where you'd select it. We're going to use Maven with Java, but again, you could use it with Kotlin, Groovy, up to you. And then we check the version of Spring Boot. Now, the snapshot versions are like the nightly builds, they're the latest, the bleeding edge. It's best usually to use a general release version, especially if you're going to production. But if you did want to use the latest, go for that. It's up to you. We're going to use 305. Then we have some project metadata. So the group, comdev for us, but your group might be different, probably is. Then we give the artifact a name. This is just going to be a demo app and a description. And then we have a packaging, right? So in days gone by, we might have selected war. When you have a war file, you would deploy that to a third-party application container, something like Tomcat, for example. But nowadays, we select jar because Tomcat is actually bundled in with the application. So rather than deploying it to a third-party one, everything you need is inside of that jar file. So that's why we select jar nowadays. If you are still deploying to a third-party container, one that's already running, then you might select war, but I don't know anybody that does that anymore. And then we select the version of Java. So version 17, 20, we're going to select 17 for the sake of this. And then we select our dependencies. Now, this is pretty great. So this is where we get a full list of all of the different dependencies, all the different starters, more or less, that we have access to. Now, for web, we typically just type in here web and then use Spring Web or maybe the reactive one if we wanted to follow the reactive way of doing things. And you can see here for Spring Web uses Apache Tomcat and it's embedded. And this one uses Netty. And do you know what? Netty's embedded in there as well. So we can just build up exactly what we want in the way of dependencies by going through this list and selecting the ones that we want. So for Spring Web, you might do that. Lombok, which isn't strictly a Spring dependency. It's a generic one, but it's on this list. So let's select Lombok for this. And then we can select any number of different ones. Maybe we want to connect to a database. So we can type in the word database. We can just have the straightforward JDBC one. For managing a database, we might use Flyway. To have an embedded in-memory database, we might want to select H2. Let's do that. And I want to connect to the database and use Java objects. So I want to use Spring JPA, Spring Data JPA. There we go. And that could be everything that we need to solve the problem of having a REST API, building it quickly with less boilerplate code, with an embedded in-memory database, and then we connect to that database and use Java objects to interact with it. Click on Generate, and now we have a skeleton app and very little coding to do. Hiya, quick interruption. So I'm trying to make software engineering as accessible to as many people as possible, and I need your help to do that. So be sure to like and subscribe because it really helps the channel out. And if you found today's content useful, be sure to share it with somebody. I'm sure they'll thank you, and it will make me very happy. Thank you so much. So you can see that very little is required to get you set up. And when you do need to change something, you can usually do this via configuration. Let me show you how to tweak that. So how do you override the default configuration of a Spring Boot app? Well, if you look in source main resources, you'll find this application.properties configuration file. Now, a properties configuration file works like this. You have keys and you have values. So for example, you have Spring data source username, which is the key, and you have a value here, which is Postgres. But you don't just have to represent it in a properties format. You can also represent it in a YAML format. And the only thing that you really need to do is change the file extension from properties to YAML. And that allows you to do it in this YAML format. So you can see here that Spring data source is done using indents rather than having to copy it each time. But all of the values are completely the same. Basically, there are a bunch of well-known keys and you can find these documented online. So when you want to override some default functionality, you usually find the key which matches that, and then you provide it with the new value, and it's usually as easy as that. For example, Spring has no way of knowing how to connect to your database. You need to tell it what type of database it is, username, password, where to find it, all that sort of thing. So you might provide it in this way. This is the YAML configuration, Spring data source. We can see here the username, the password, the URL, and the driver class name. In this case, it's for a PostgreSQL database. But that was providing new information. What if you wanted to override some information? Well, by default, a Spring web application will run on port 8080. But let's say you were running two applications side by side and you wanted the second one to run on port 8181. You could do that just like this. Server port 8181. If this was in a properties format, it would be server.port. But this isn't the only way that you can provide configuration to your Spring Boot apps. You can also do it via environment variables. So we can see here an example for server.port 8181. So that's what you would see in a properties file to change the port that it's running on to 8181. The environment variable equivalent is server_port 8181. So as a general rule, you would take any separators and replace those by an underscore, make everything uppercase, and that is the environment variable that you would use. And there's even some other ways of providing configuration to your Spring Boot apps. But to understand those, we need to understand what happens to this sort of information when it's provided to the app. It's read, and then it's, any guesses, turned into beans. So if you want to change your config, you can either intercept these beans and change the config, or you can just create the beans from scratch. So here we have an example of that. Now, before we were creating beans in our main class, but actually you can create them anywhere in any class, providing it just has that @configuration annotation on the top. So we saw that we were providing database information before, and that's exactly the same thing that we would do with this data source bean. So you can see here the information's the same. We've got the username, password, URL, and the driver, but instead of providing that in our configuration, we're just building a bean with that information and then making that bean available to our application. So we've talked about Spring going out to find beans, but how does it actually do it? Well, let me tell you about component scan. Here we are back at our main class. Now this lives in the top level package of our project, and that's very important because it's from this point in the hierarchy down that Spring will look for beans and the places that beans are needed through a process called component scanning. So one place Spring looks for beans is any class with an @configuration annotation on the top. It also looks for any classes with @component on top or one of its subclasses. Now these annotations say to Spring, hey, this class is a bean. This class is a candidate for injection, but equally it requires some dependencies, and those dependencies should be injected as well. So we're building up our Spring terms, and we've been using the term inversion of control container so far. Now there is a Spring specific term for this, so we're also going to be using the term application context. So we've talked about this main class and where it lives in the hierarchy and what it does and the fact you can define beans in it, but what line in this code says you can do all that? Well, the answer is the SpringBootApplication annotation, which isn't just one annotation. Well, it is, but it's an alias for a number of different ones. So SpringBootApplication is actually an alias for these three. @configuration, which says, hey, this class can contain beans. Enable auto configuration, which is part of the Spring Boot process of configuring everything when your app starts up. And then @component scan, which says, from this point down in the hierarchy, look for beans in places beans are needed, at least with the default configuration. Most of these annotations you can provide additional arguments to change the default behaviors, but most of the time the default configuration will be absolutely fine. Now we've talked a lot about how to run a Spring Boot app. We haven't actually tried to do it yet. Let me show you how it's done. There are a number of different ways of running a Spring Boot application, and today I'm going to show you three. The first one is from your IDE, and we're using Visual Studio Code today. So the first thing you need to do is open up your main class. And here's our main class, and we can see above the main methods we have run and debug. So we're just going to click on run. And just like that, our application is started. Let me show you the second way. The second way is from the terminal, and we're going to use a plugin for our build tool. So remembering we're using Apache Maven here, we can actually use the Apache Maven Spring Boot plugin. And this is how we do that. So we use the Maven wrapper in this case, or you can use Maven if it's installed on your core system. Maven wrapper just happens to be a part of any project we download from the Spring Boot Initializr. And we would go spring-boot : run. And this is going to start our application. Just like that, the application is started. Let me show you the third way of doing things. The third way of doing things, again, is from the terminal, but this is going to differ from the first two ways. So whereas the first two ways you'd typically only use in development, the third way you'd use in production. So we're going to build the artifact that we would then deploy to our production environment, and we're going to run that artifact locally. So we're using Maven today, so we're going to use the Maven wrapper, and then we're going to call the package goal and run this to get our artifact. So that was a build success. So I'm going to go to the target directory, take a look in here, and we can see we have a jar file, this one right here. So I'm simply going to call, and there's a number of different ways of doing this, but the one we'll do today is java-jar, and then pass in the path of that jar file. And we can see just like that, the application is running. So let me take you on a tour of a Spring Boot app. This is a Java-based app, and it uses Maven as the build tool. So we're going to start with the POM XML. So inside of here, we can see we've got the group ID, the artifact ID, versions, all of that good stuff. But then let's take a look at the dependencies. We can see that we're using the Spring Boot Starter Data JPA, and we've got the Spring Boot Starter Web. So this is going to be a REST API which connects to a database. We can also see that we're using an in-memory database, so the H2 database there, and we're using Lombok to reduce some boilerplate code. And we've also got access to the Spring Boot Starter Test, which gives us some nice little utilities to make things easier for testing our application. Okay, so that looks to be most of the dependencies. Let's take a look at the application. So we're going to go from the bottom up, I think. So let's start with the persistence layer. So the persistence layer, traditionally, we would have that in repositories here. The repository, we're using Spring Data JPA, so we don't need to provide an implementation for this. We simply just extend this interface, JPA repository, passing in the domain object that we're dealing with, and then the type of the ID. In this case, we're modeling the book entity, which is a POJO that's been annotated as an entity for use with Spring Data JPA. And we can see here it's got ISBN author, but the ISBN is the unique ID here, as identified by this ID annotation here. It's worth pointing out that @repository is a subclass of @component. It does exactly the same thing, but @repository is just more descriptive that this particular class is a repository rather than a generic component. So that is what we've got for our persistence layer, which would interact with that H2 database from our dependencies. If we go up a layer into our services, we should see the business logic. So let's take a look at that. And we typically find that inside of a directory called services, released in the format that I use. And we've got here a book service interface, remembering that we were coding to interfaces. The book service has several methods. IsBookExists. We've got save a book. And then we've got find by ID, which might find a book or it might not find a book. And then we've got list all of the books in the database and then delete a book by its ID. So typical service for dealing with books. What does its implementation look like? Here's the implementation. So we can see we've got the book service impl, which implements the book service. And it's got this @service annotation. @service is another subclass of @component. Again, does exactly the same thing. It identifies this particular class as a bean, but it's more descriptive. This is the service. This is part of our business logic. This is part of that business logic layer. We can see in the constructor of this service that this service has a dependency. So the book service has a dependency of the book repository, and this is how it would be injected here. Strictly speaking, the auto-wired isn't required for the constructors anymore. This book service relies on a single dependency, which is the book repository, that's then used to implement the different methods that are defined in that interface there. And that is our service layer. What about our presentation layer? Knowing this is a REST API, let's take a look at the controller. And here we have the books controller. And we can see here from this annotation, that is a REST controller. So it is a REST API. We've got here the book service is a dependency, and we can see that we've got the constructor for book controller, and book service is a dependency, so it's injected there. Again, @auto-wired isn't required anymore. It was in days gone by. And we can see this controller has a put mapping, which returns a response entity. Book response entity allow us to change things like the HTTP status code of the response. So here we have a put mapping on the path /books and then the ISBN. So this is typically used for creating and updating a book, which we can see reflected in the method name here. We can see that the ISBN is a path variable, and we can see that's a string that's extracted as the ISBN variable there. And we can also see that the request body, so the body that's put to this particular endpoint, is represented by the book domain object. So that's going to be converted into that book domain object from JSON using the Jackson library. We can see that this is typically going to use the service and then return the response here. So this check if the book exists, and then it saves the book. And then if the book exists, it's going to return a HTTP status OK along with the saved book. And if the book didn't exist, it's going to return it with the HTTP status created along with the saved book. And you've got some different endpoints here for the Git mapping for listing a book, retrieving a book, and deleting a book. And this typically represents a CRUD API, which is an acronym for create, read, update, and delete. And we can see the main class here with the @SpringBootApplication annotation on top and the main method. There's no beans declared in here. There are beans in this application, of course, but we've used the @component and its subclasses to make those beans available to the application. If we look in source main resources at the application.properties, we can actually see that we didn't need to override any of the properties, so the default configuration is absolutely fine for this application. If we do look in resources, we have this static directory. Anything we place in here will be served by Tomcat, so we can just hit this in our browser. In this case, at the index HTML, it should just be / or /error HTML, /success HTML. And there might be some CSS in here as well. So it'll be /CSS /style.css. So that static directory is there, at least in a web application, to just serve static assets. If we're using a templating engine like Timely, for example, then our templates will be found in this templates directory. And then we have our tests in our test directory, which reflect our actual source code here. So here's our book controller IT integration test for testing our books controller, but more on tests a little bit later. And now for everybody's favorite subject, let's talk about logging. And I'm going to keep this light on purpose because it's logging. So by default, Spring will log to the console and only to the console. If you want to change that, then you'd have to change one of the underlying implementations for logging. Now, if you're using the starter, then chances are you are using the starter, the implementation will be logback. So if you want to change from logging to the console to logging to a file, for example, or change a logging level, you would do that inside of a logback.xml file. Now, you can find all of the information online about how to configure a logback XML file, but the important thing about Spring Boot is you just put it in your source main resources, Spring Boot will pick it up for you, use that configuration, and that will be your app configured. But you don't have to go to those lengths if you just want to change the log level from debug to info to warn to whatever you want to change it to. You can actually do that in your application.properties or application.yaml file, and we can see an example here. So the prefix is logging.level, and then you just put the package that you want to change the log level for. In this example, we've changed the org.springframework.web to trace level. This basically means that every time that we hit a running web application, we just get every single one of the log lines available, so we know exactly what's happening. So basically, start logging.level, put the package you want to change it for, and then put the log level that you want to use for it. As for creating a logger, you can do it the long way, where you basically use the logger factory to create a logger, and then you can use that logger instance variable throughout your code. But there is a shorter way of doing this. Now, all you have to do is use the @self4j annotation, and it gives you access to this log variable. Bear in mind, this is using the Lombok dependency, so you need to have that on your class path if you want to do it this way. But you can see it's a lot simpler, and it just gives you access to that log variable throughout your class. Now let's wrap up with some testing. So you have different types of tests, right? And we've got a few of them here represented as a test pyramid. Now, the higher you go up the pyramid, the more expensive these tests are to write and the slower they are to run typically. At the base of this pyramid, you can see unit tests. Now, Spring Boot uses JUnit 5 unit tests, and they work pretty much the same as they would do anywhere else. Perhaps the only difference is when it comes to mocking. So if you use this Makito extension, you can set up your beans as mocks with this @mock annotation. And then you can create your class under test using the @inject mocks, and it will take your mock beans, inject them into that class. And then you can just use that class and those mocks throughout your tests as you usually would. Unit tests don't need an application context, and they don't need a running Spring app. But what if you do? Well, we're moving up the pyramid a little bit into that integration test area. Let me tell you about Spring Boot Test. So the @Spring Boot Test annotation starts up a test version of your Spring Boot app that you can then use in your tests. So you can see we've used it here in order to test the REST API side of things. Now, we could do this in the unit test by just calling the methods in the controller, but we've chosen to do it this way because then we can test that the things like the HTTP methods are set up correctly, that we're extracting parameters correctly. We can do that all, but we do need a running Spring Boot app for that. You can also see that we've got the @autoconfigure mock MVC annotation on top, which then allows us to have a mock MVC object that we can auto wire and use in our tests. Mock MVC is a nice little utility for testing web, so for testing things like REST APIs. And that comes from the web test package. Now, you'll find a lot of the Spring dependencies have a corresponding test package that have some utilities in there which make it easier to test them. Thank you for that, Spring. So that mock MVC there is used to call the endpoints, and then we can see we're exerting on things like the JSON that's returned and the HTTP status code, etc., etc. The other annotations that we've got here is @extend_with. We've got the Spring extension that allows us to integrate our Spring test class with the JUnit 5 runner, and that's really needed to make everything run smoothly. And then we've got this @dirtiesContext annotation. We have a Spring context for our test class, right? But it isn't cleaned down before each test method by default. So what we've done here is set it to do that. So before each test run, the context is reset, essentially. And we've done it in this way so that there is less test pollution. There's less chance of one test influencing another. And you generally do this when you are changing the context or manipulating the context in your test. It does have the downside of tests running a little bit slower, but does make things a little bit cleaner when it's needed. So @Spring Boot Test is going to start a running version of your app. And it might be that you want to have different configuration for your test app than what you would do for your production app. You certainly don't want your tests connecting to production databases and things like that. So a nice way of doing things is that you create a resources directory in your test directory, and then you can put a configuration file in that test resources directory. And it's that configuration file that's favored over the one in main. So if you want to override your test configuration, drop one into test resources, and that'll be the one that's used. And there we go, a whistle-stop tour of Spring Boot. Hopefully you found the stuff that we've covered today to be useful and you can get up and running as fast as possible. Now, like I say, we didn't cover absolutely everything, so I am going to leave a list in the description below for some other bits and pieces that you might want to look into. Now, if you do want to go straight onto Spring Web and discover how we can build a REST API completely from scratch, then do check out this tutorial here where we do just that. I'll see you over there.